so this is a really quick clip to add on to clip number 1, which is about how do you work out critical values for unrelated data, i.e. for independent groups design. So if you remember, we said that to work out critical values, you need to know the level of significance, you need to know n, which is the number of participants, and you need to know whether it's one or two-tailed. Now, remember, that only works if it's repeated measures design, because then you know for n, you've got 20 participants. And because it's the same participants in each condition, you're always going to have 20 participants. Now, if you have an independent groups design, it might be that you have 10 participants in condition 1 and 11 participants in condition 2. So you can't just have a value of n. So what do you do? Right, so let's start with the easy one. So if you have a Mann-Whitney test, and again, don't worry about what the Mann-Whitney is just now. We'll talk about that. Just know this for how you do critical values. Right, so you've got a Mann-Whitney test. This is really simple. If you have a look, you've got N1, it's called, along the top. Now, for this critical value table that I'm showing you is in your packs. So if you go to the back of your packs and go to page 40, after 48, you've got all your critical value tables there. I don't know if you can see that. So I'm following this. So what I've done here is this is critical value P2 in your pack, which is page 50. So I'm just using this. So if you have a look at Mann-Whitney, then you'll see it's got N1 and N2. Now all this simply means, really easy, is N1 would be condition A and N2 might be condition B. It doesn't really matter which way around you do it because it's going to be the same whatever. So just say in condition 1, you've got 10 participants. There you go. And condition 2, you've got 8 participants. All you do is put your finger on 8, put your finger on 10, go across where the 2 meet, there you go, your critical value is 13, yeah? Really simple, really simple. So let's do one more. So you do it yourself then. So for Mann-Whitney, this is table 2 by the way, you've got 5 participants in one condition and 6 participants in the other. So find that. What is the answer? Okay, so hopefully what you've done, go to 5 here, go to 6, go along, bump, critical value is 2. Yeah? Got that? Good. Right, Mann-Whitney is easy peasy, that's all you do. Now, for 2 of the other independent groups design tests, not so easy, not hard, but just slightly more complicated. So let's go to the critical value P7. Can you find that? Yeah, and you'll see it says that's for the t-test. Now it says independent and related t-test. That's because you've got a t-test for independent and for related data, funnily enough. And it tells you on the top of it how you work it out, but I will show you. So, how you work out your critical value for a t-test, an unrelated t-test, it's really simple. So, I'm left-handed, sorry. All it is how many participants are in condition A or condition 1, so that's N1, plus how many participants are in condition 2, so we call it N2, and then we just add them together and take away 2, yeah? So, just say we've got, in condition A, you've got 6 participants, in condition B, you've got 10 participants, all you do is this. So nice and easy, what's that? That's 16 minus 2. So that would come out to 14. And we call this, to give you another complicated term, we call this a DF, or a degree of freedom, yeah? So if you look on critical value table P7, down here where your N would normally be, it says DF, and all you simply do is go to 14, and then depending on obviously whether it's one-tailed or two-tailed or all of that, you just follow it along, and there you go. So let's do a quick example using your critical value table. Right, so work this out for me, okay? So you've got, in condition A, condition 1, you've got 10 participants. In condition 2, you've got 8 participants. Now work out what your degree of freedom is for me. It's not hard, is it? It's nice and easy. So yeah, your degree of freedom, 10 is 18, 18 minus 2 is 16. Go to critical value table, again, go down to DF, 16, there you go. So if you had, say, a one-tailed test at 0.5, you follow it along, and your critical value would be 1.746. Got it? Lovely. Right, last one then is chi-squared. Now, this is critical value P5 in your pack. If you go to that and have a look for me. Right, now this is worked out slightly differently. Now, for chi-squared, this is nominal data, okay? So remember nominal data, this is category data. So the category data is always going to be shown in a table like this, yeah? And we call this a contingency table, and this is in your packs as well. So just say we've got a table like this, I don't know, just say you're looking at, I think you've got in there, males and females, and you're looking at what flavour ice cream they choose, whether they choose vanilla or whether they choose strawberry, yeah? There's your table, so all you'd simply have is you'd go, oh god, yeah, 5 people chose vanilla, 5 males chose vanilla, 6 males chose strawberry, 2 females chose vanilla, and 8 females chose strawberry, okay? Now, how you work out your degree of freedom for a chi-square, because it will all, this is a top tip actually as well. If you see a table like this, and they're asking you what stats test, it's always going to be chi-squared. But anyway, how you work out the degree of freedom for this all it is number, well, my handwriting, so I'm writing at slant again, number of rows minus 1 times number of rows minus 1. So for this one, how many rows have you got? Look, you've got 1, 2 rows. So it simply is, for this one, number of rows is 2 minus 1. There we go. Number of rows, and again, 2 minus 1. So that is 2 minus 1 is 1 times 1 equals 1. So your degree of freedom would be 1. So if you have a look, there you go. There's your degree of freedom there. And again, it works in the same way. So you know, whatever it is for a one-tailed test, and for a two-tailed test, you'd work it in exactly the same way. Now, all of this is in your packs for you to have a look at, for you to have a go at. But that is it, really. Okay, good.